We knew that, yeah.
And the opposite sides are parallel. Remember, parallels got those arrows, and both pairs of sides are parallel. So it's obviously not that the left is parallel to the top, because they intersect, but your top and bottom and your left and right are parallel. This part isn't in your notes, but let's run through this quick. What did we decide about our opposite sides, besides the fact that they're parallel? What else are they? Equal. They're equal, yeah. So my top and bottom are the same, and my left and right are the same. How about angles that are next to each other? What did we decide about those?
They equal 180.
They equal 180, yeah. And my opposite angles, what about opposite angles?
They equal each other.
They are equal. And what else we got? Our diagonals,
Equal.
they bisect each other. Okay, and I think we'll talk about that in our flipbook too. You guys remember what bisect means? Goes through where?
Crosses halfway.
Crosses halfway, yeah. I think we had that in that little copy and paste thing. My picture super sucks. I'm sorry. But like if this was 13, this part is 13. Okay? So bisect, it's kind of, you can think of it as like a midpoint. Alright, moving on to the stuff you have. You don't have that one. Oh, we have this one. We got lots of X's. True story, I don't need to use all of them. I just have to use some. What do we know about our angles in parallelograms? What's equal? Opposites. You want to use opposite ones? Which ones are opposite? How about let's use x plus 35. What's opposite of that?
2x.
There we go. So what should I do with those two things?
7 equal.
7 equal. X plus 35 equals 2x minus 5. So I subtract my x, add my 5, and I get x to be 40. On a quiz test, I would go back, plug it in. You can check this, like, I don't know, 3 different ways. You can make sure when you plug in that these two are the same. You could plug into these and make sure they're the same. Or you can make sure these are 180, these are 180, these are 180, or these are 180. So I'll add, there's more than 4 things. There's like, you trust me? Okay. No. Okay, you don't have this one, sorry about that, but you do have this one. Do I have sides or diagonals there? Diagonals, and we said the diagonals what each other? Bisect each other. So, what's the same as x plus 1? Y, yeah. They have to be on the same line. So let's write, I know y, oh boy, what am I doing? Y has to equal x plus 1. Okay? Because I know that that t is kind of like a midpoint for both my lines. What else has to be true?
3y minus 7
Equals 2x. There you go. 3y minus 7 has to equal 2x. The problemo in both of these is that I have 2 variables. You guys remember a thing called substitution?
Not really.
Not really, that's okay, we'll go through it. If my y equals x plus 1, I can take this x plus 1 and plug it in for y. Because y equals x plus 1. So, instead of it looking like 3y minus 7, we're going to go 3
x plus 1
parentheses x plus 1, yeah. Minus 7 equals 2x. So you're basically copying down the red thing, except for where your y is, you're going to put the green x plus 1 in. Does that look kind of familiar? I know it's been a while. A little bit. So I got to distribute this 3, so I get 3x plus how much? Plus 3, and then minus 7. Still equal to 2x. You good?
Yeah.
Okay.
X
I think
equals
that
4.
sounds like it doesn't sound fun. What'd you say?
X equals
Okay. So what was 3 minus 7?
Negative 4.
So I get 3x minus 4 equals 2x. Subtract your 2x, add your 4 over, and x equals 4. grab one of those, all three of those. 1, 2, 3, yep. And then get out your mouse packet. Okay, I want you to draw a parallelogram. I truly don't care what it looks like as long as it has 4 sides. Then we'll label it W, X, Y, Z. Well, I drew mine tiny. You can draw yours tiny.
It's tiny.
No, on mine. See? It's in there purple.
Wow.
Aren't you impressed? Alright, I'm going to ignore for a quick second that the perimeter is 90. I'm looking at WX is 5 inches more than 3 times XY. Do I know how big XY is? No, what should I put there? X. Question. If XY is X, what else?
W.
WZ is also X. Good. Okay, and now it says WX is 5 inches more than 3 times XY. How do I write that?
3x plus 5.
There you go. 3x plus 5. And what else?
Bottom equals 3x plus 5.
Bottom is 3x plus 5 too. Alright. What does perimeter mean? The outside. So what am I going to do with all those things? Add them up and so equal to 90. So when I add these up, how much x do I have total? 8. X plus how much?
10.
And you start to set that equal to 90. Alright. Subtract our 10. 8x, 80. X is 10. So each side, these two are 10. And the other ones are 35. What do we think about that?
Where did you get the 35 from?
3 times our 10
No.
is 30 plus 5. 35.
These suck.
Okay, let's not freak out. But we got proof. Best thing is that this is pretty easy proof. What's our first line of proof so is?
Yeah.
The given, copy down, A, B, C, D, and N, M, L, B. Those just say that they are parallelograms, and my reason is given. My goal is to get that M and D have to be the same. Okay? So let's look at M. Looking at my parallelogram NMLB, what do I know has to be the same as M? Why? Yeah, I said my opposite angles have to be the same. So I can say that angle M is congruent to angle B because they are opposite angles. Looking at my big parallelogram, what's B the same as?
D.
D. B and D have to be the same because why? Opposite angles. Angle B is the same as angle D because of the same silly thing. Opposite angles. Alright, well here's the tricky thing. If M is the same as B and B is the same as D, M and D have to be the same. Why? Yes, transitive. Take out the middleman. If they're both equal to the same thing, then those two things have to be equal. M has to be the same as D by the transitive property. So I kind of think of it as like, take this out and then these two things have to be the same. Alright, that was just silly. I don't have that little thing on here. That's okay, I can read about it. It says if we have parallel lines, then they cut congruent segments on every transversal. So, if I know that AE, BF, CG, DH, these are all parallel, and then I know EF, FG, and GH are 6. First off, let's label those. EF 6, FG 6, GH 6. And then it says AD, that whole line up here is 15. So what that little thing says on your paper, that theorem 6-7, if you have parallel lines and you know that these are equal, these two things, then these have to be equal. In this case, we have 3 of them. Not only are these 2 equal, but these 3 are equal, which means these 3 have to be equal. So how big is each thing? 5. Isn't that like just a silly thing?
Yeah.
Yeah. So how big is CD? 5. Like, oh, well, that's cool. Helpful, right? No. Last one we're gonna do. If 8E is 100, so from here to here is 100, I need to find BD. Well, I know that all these are the same, which tells me that all these have to be
20.
the same. They're each what?
For each 20, like, so there's 5 of them, so that equal, they make them 20, right?
So there's 5 letters, but how many things do I have? I have 1 here, 2, 3, 4. So just because there's 5 letters, there's only 4 parts. So each is 25. So 25, 25, 25, 25. So how big is BD?
75.
What?
50.
50. BD is just 2 of them, buddy. Okay, then pull out your flip book. Where did I put that on? Here. There it is. Open it right up to that top one. So just flip your cover, whatever you want to say. Properties of our parallelograms. Like I said, we talked about most of these. 2 things to know about our opposite sides. They're equal, congruent, same. That's a subsphone. That's fine. What else do I know about them? Something super obvious that's in their name. Parallelograms. They are also parallel. What do we say about our opposite angles?
Congruent.
Congruent, same, equal. Congruent just makes me feel fancy somewhere. It's just popular, I don't know. Consecutive angles, ones that are next to each other. What do we know about those?
Equal and A.
Supplementary, add up to 180. Supplementary, equal 180. And last thing, the diagonals what each other? Bisect. So, not right. This is the same as that. And this is the same as this. The green and red are green and blue are not the same. But the greens are the same as themselves, and the blues are the same as themselves. I feel like we got those down pretty good. We got an example. If I know, let's find easy things to find. Oh, that's dumb. How big is AD? It doesn't ask for it. How big is AD?
14.
How do we know?
Because 14 on the top too.
Yeah. This one it asks for. AB.
9.
9. How about AC, the whole line?
21.
Quick math.
22.
22, how'd you get it, Austin?
22.
It's 11 on both.
Yeah. 11 AE, 11 EC, double it. 22. And BE has to be
7.
7. Questions on sides? Okay, let's look at our angles. angle bad, 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 that is this whole angle right here. 54? 76? Getting mixed signals. Okay, let's think about this. I know for a fact these are parallel lines, right?
Yes.
Meaning that this little thing crashing through the transversal. So what do I know about this angle and this angle?
That's it.
Why? What do we call them?
Alternate.
Alternate
Interior.
anteriors. So this one has to be 49. So 49 plus 27, that whole angle is 76. ADC, let me write that here. 76. Whole angle. ADC should be easier to find. Because what do I know about that 76 I just found in ADC? Are they opposite or next to each other?
They're next to each other.
They are next to each other, which means they are,
They're equal to 180.
they add up to 180. Good. So how big does this have to be?
104.
104. Okay, it doesn't, well, okay, let's do it this way. How big is this angle B whole thing up here then? 104, because they're opposite, so they have to be the same. So if I need to find ABD,
Subtract 42 from
take 104 minus 43. Does that make sense? Okay, what am I left with? 61? 51? 60. Most of the stuff is the same, so when in doubt, equal them. Only one of the things isn't the same, and that's if they're next to each other. Alright, how about here? If we have a parallelogram, how can I find PSR, this angle right here? What can I do with my X stuff? Go, Bella.
Aren't the two things you already have, aren't those going to equal 180?
Yeah, why?
Because they're adjacent.
Yeah, they're next to each other. So they gotta equal 180. It's like my field goal thing that we talked about a while ago. So add them up, set them equal to 180. 7, 8, 5, 11. 11x minus 18, right?
Yes.
So 11x equals 198. That's right, I'm wrong. Mental math up to then. 18? Okay, let's work smarter, not harder. If I'm looking for S down here, what should I plug into, Q or P? Why Q?
It's the same.
Because they gotta be the same. It's weird, because they gotta be the same because they're opposite. Hopefully that made sense. It wasn't funny, but.
113.
What do we get?
113.
113. Woo! How do you feel about parallelograms? I love them. Do you love them? I agree. Alright. In